This is Teacher Rosaline and welcome to our statistics class. Storytelling! William Gossett was an English statistician who worked for the brewery of Guinness. He developed different methods for the selection of the best-yielding varieties of barley, an important ingredient in making beer. Gossett found big samples tedious, so he was trying to develop a way to extract more samples but still come up with meaningful predictions. He was a curious and productive researcher who published a number of papers that are still relevant today. However, due to the Guinness Company policy, he wasn't allowed to sign the papers with his own name. Therefore, all of his work was under the pen name Student. Later on, a friend of him, a famous statistician Ronald Fisher, stepping on the findings of Gossett, introduced the T statistic, and the name that stuck on the corresponding distribution even today is the student's T. And that is under the Quarter 3, Module 3, the T distribution. It is also known as student's T distribution. It is a probability distribution that is used to estimate population parameters when the sample size is small and or when the population variance is unknown. Based on the central limit theorem, a sampling distribution of a statistic like a sample mean will follow a normal distribution when the sample size is increasing. Therefore, when we know the standard deviation of the population, we can compute a z-score and use the normal distribution to evaluate probabilities with the sample mean. But sample sizes are sometimes small, and often we do not know the standard deviation of the population. When either of these problems occur, the statisticians rely on distribution of the T statistic, also known as the t-score. We have the T formula, that is T equals the x bar minus mu over the sigma divided by the square root of n, where x bar is the sample mean, mu is the population mean, sigma is the standard deviation of the sample, and n is the sample size. We have here also the degrees of freedom. The degrees of freedom refers to the number of independent observations in a set of data. It has a formula df equals n minus 1. Example, if we have the sample size which is 16, df equals 16 minus 1, that is equal to 15. We have also the properties of T distribution. The mean of the distribution is equal to 0. The variance is equal to V over the quantity of V minus 2, where V is the degrees of freedom. The variance is always greater than 1, although it is close to 1 when there are many degrees of freedom. With infinite degrees of freedom, the T distribution is the same as the standard normal distribution. Comparison of the T distribution and normal distribution. The T distribution is similar to a normal distribution. Just like the Z distribution, the T distribution is symmetric. Just like the Z distribution, the T distribution has a smooth shape. Just like the Z distribution, the T distribution has a mean of 0. The Z distribution, the population standard deviation is known. In T distribution, population standard deviation is unknown. T distribution is defined by the degrees of freedom. The Z distribution is most useful for large sample sizes, or n is greater than or equal to 30. The T distribution is most useful for small sample sizes, or n is less than 30. As the sample size increases, the T distribution becomes more similar to a normal distribution. For example, the mean drying time of a certain brand of wash clothes is less than 25 minutes. Find the probability if a random sample of 16 brands of washed clothes show a mean drying time of 26 minutes with a standard deviation of 2.4 minutes using 0.01 level of significance. For step 1, we have to identify the given of the problem. The population mean is equal to 25 minutes. The standard deviation is 2.4 minutes. The sample mean, that is 26 minutes, and for the sample size, that is 16. For the step 2, substitute the x value, the mean, the standard deviation, and the sample size into the t-score equation. T equals the x bar minus mu over the sigma divided by the square root of n. Substituting the values, we have 26 minus 25 over 2.4 divided by the square root of 16. And for the step 3, perform the operations and solve for t value. We have the substitution part, 26 minus 25, that is equal to 1 over 2.4 divided by square root of 16, that is 0.6. So 1 divided by 0.6, that is equal to 1.67. And for the step 4, find the critical value using the T table, or you can see on the appendix table 2. Find the degrees of freedom and level of significance. Since n equals 16, the degrees of freedom, that is 15, and the level of significance, that is 0.01. It is one-tailed because of the problem is directional. The clue word is less than. Since we have now the degrees of freedom, that is 15, and the level of significance, that is 0.01, one-tailed, first is to locate 15 on the column of the degrees of freedom. Second is to locate 0.01 on the row of one-tail. And their intersection would be the probability value, and that is 2.602. On page 44, once more, compute the t-value and critical value. Use the formula of t and the formula of the degrees of freedom. For number 1, we have the sample mean, which is 27, the population mean, which is 28, the standard deviation, that is 2.9, and the sample size, that is 16. And the level of significance is 0.05, one-tailed. So we have now the formula. T equals the sample mean minus the population mean over the standard deviation divided by the square root of the sample size. That is 27 minus 28 over 2.9 divided by the square root of 16. So we have to perform the operations, and the final answer would be negative 1.37. And for the degrees of freedom, we have 16 minus 1 equals 15. And we can now use our T table. Since the degrees of freedom, that is 15, first is to locate 15 on the degrees of freedom column. Second is to locate 0.05 on the row of one tail. And their intersection would be the probability value, and that is 1.753. And for number 2, we have the sample mean equals 10, the population mean, that is 9.5, the standard deviation is 0.5, and the sample size is 20. The level of significance is equal to 0.01, one-tailed. And for number 3, we have the sample mean equals 20, The population mean is 21.5, the standard deviation is 1.6, and the sample size that is 10, and the level of significance is 0.052. And on page 45, what I can do, solve the problem. Suppose you do a study of medicine to determine how effective it is in relieving pain. You measure sensory rates for 15 samples with the mean results of 8.2 and the standard deviation of 1.67. Using 0.05 level of significance, compute for t-value for the mean sensory rate of less than 8.0. To answer this problem, you will just follow the steps. We have the step 1, the step 2, step 3, and the step 4. And you will do that in 1 week. That's all for today, and I hope you have learned something today. Again, this is Teacher Rosalyn saying, the more that you read, the more things you'll know. The more that you learn, the more places you'll go. Bye-bye! See you next lesson!